Hello everybody, it's Mrs. Pound and I'm back with another video from Chapter 2 about matter from BGU Chemistry 5th edition. So what we're going to cover today is from Section 2.2 Energy and Matter, and this will be Part 2 of that. So our objectives today are to explain why the Kelvin scale is called the absolute temperature scale and to convert temperatures between the Celsius scale and the Kelvin scale. So let's first start with the Celsius scale. This is a temperature scale with 100 degrees between the normal boiling point of 100 degrees Celsius and the freezing point of 0 degrees Celsius of water. Now, sometimes this is also called the centigrade scale because centi means 100 and gradients. There are 100 gradients between the freezing point and the boiling point of water. So that's why Celsius is also sometimes called centigrade. And it's just easy numbers to remember that 0 is freezing and 100 is boiling. Unlike the Fahrenheit scale where freezing is 32 degrees Fahrenheit and boiling is 212. So just much easier to remember. That's why we use it in science class. There is also something else we need to talk about. It's called absolute zero. This is the temperature at which particles have minimum motion. Now, I want you to write next to absolute zero, impossible in capital letters. It is actually impossible to reach this temperature because there's always going to be heat leaking in from somewhere in the universe. And in order to have something at absolute zero, you would actually have to have something colder, which is impossible. So make sure you have impossible written next to absolute zero in capital letters. And I do have snow in the background, but absolute zero is much colder than snow. It's actually negative 273 degrees Celsius, so very cold. Now, absolute zero really goes with the Kelvin scale. This is an absolute temperature scale with 100 kelvins between the normal boiling point of 373.15 Kelvin and freezing point 273.15 Kelvin of water. When we're doing our conversions, though, I'm really not concerned about this 0.15. 273 is going to be okay. And the reason this is called an absolute temperature scale is because the Kelvin scale starts at zero at absolute zero. Okay, so this actually makes it nice for when we're doing graphs that involve temperature. They would not really look right with Fahrenheit or Celsius, so we use the Kelvin scale when we do graphs. And when we do a lot of calculations, because it gets rid of negative numbers. So a lot of times when we do our calculations with different formulas, we are going to have to convert to Kelvin so we don't have to any negative numbers. So speaking of converting between Celsius and Kelvin, there is a formula. The Kelvin temperature equals the temperature in Celsius plus 273. Now this is on the back page of your reference table, so this is not a formula you have to memorize. So let's take a look and let's convert from negative 123 degrees Celsius to kelvins. The first thing we always do is we always write down our formula. Don't skip this step, you'll get in trouble, okay? Make sure you write down that formula, K equals degrees Celsius plus 273. Then we plug in what we know. So K equals negative 123 plus 273. We add those together and we end up with 150 Kelvin, okay, 150 K. So pretty straightforward. But what if we go the other way? Let's convert from 145 Kelvin to Celsius. So we have K equals degrees Celsius plus 273. Okay, but the problem here is we want degrees Celsius, not Kelvin. So we'll just rearrange the formula. And we will subtract 273 from both sides to get degrees Celsius by itself. And so the formula becomes degrees Celsius equals Kelvin minus 273. So Celsius equals 145 minus 273. So 145 K is negative 128 degrees Celsius. That's pretty cold. So our objectives for this video were to explain why the Kelvin scale is called the absolute temperature scale and to convert temperatures between the Celsius scale and the Kelvin scale. Now, don't forget your 5 questions, and I realize there's not a lot of information here, but you can get 5 questions by making up your own temperature conversion problems as well. So 5 questions, and I'll be back with more videos.